Okay, so we got a new year, and as a reminder, if you look down in the description, we got links for the index and to our Slack and all that kind of stuff. And other than that, I since I now officially know that I did absolutely nothing last year since we got a new year. So again, I'm sitting here with nothing other than we've been talking about Raspberry Pi power, so we'll probably talk about that before the day's over today. And other than that, I guess I don't have anything to say. So who wants to go?
I
There
want
you
to go
go.
first simply because
Okay.
I just got an invitation to meet for someone for lunch. So I probably will not be able to stay the whole time. But I decided that I wanted to, this is part of the robot snowblower. Um, I was loaned a 3D printer, so I decided that I wanted to get started on that and mock it up and maybe decide to use a plastic blade for my blower. But since I'm wanting to do 15 inches wide, my printer isn't that big. So I'm having to do it in the blade in 3 sections. So this is 2 of the 3 sections. It's the going to be rotating this way. And I was pretty impressed that at how solid it is with only a 25% infill.
A really big part to 3D print.
And then there'll be this section. You can kind of see this is the middle section. This will be mirrored over here to give me my 15-inch wide blower.
Wow, I'm impressed. And then your bolts and nuts to join the two pieces together.
Those will be metal, yeah. Plus, it's actually a tight enough tolerance fit that I didn't even need this bolt. I was just wanting to make sure that everything lined up correctly. And then there's a half-inch rod that'll be going through as a shaft in the middle to take power from a drive chain on the side to move the blower.
And then how do you um, what I don't, there's probably a proper engineering term, but how do you fix the blade to the shaft that goes through the center?
I have, they're normally going to be shear pins,
Mm.
but I don't know if you can see them well enough.
Yeah,
But
getting a
there's
lot of reflection on that
it,
material. So
this one's in red. I've got an older version in black. Where did those go to?
and did you use PLA or PETG? What sort
At
of
this point, it's PLA. Um, this is a version with the black and only a single blade. But I thought that because of the bulk, that would throw it out of balance. So version 3 has the double blade. But I've got pins that'll be going through the shaft, 2 per section.
nice?
And we'll see how that holds up.
And then the design software, did you get a design from somebody or
No,
did
no. I'm doing it all on OnShape. I've
OnShape?
got a free account, and
Do you have the model there handy? You can show on the screen.
let me see. Yes.
It's always just fun to see the whole design.
Let me see if I can get to Zoom. Okay, where's Zoom? Here's, why is this? Let me move windows and see how to share. Okay, why won't it let me share?
A green box on the bottom middle part of the Zoom
There.
window. I mess around with Fusion 360. I'm not a very good designer at all. Like making one part and then having it in two pieces. That's awesome.
So you can kind of see
You
here's,
designed all of that.
yes.
You're a flippin', CAD CAM designer, man. That's a complex part. That is awesome.
And now I'm working on the motor mount chain that'll be on the side. So that's the same shaft. And
Well, I am duly impressed with your skills there, man. Go back to your blade.
I can do that very easily.
Those on the left, so the top left sort of cornerish, you got those stairs there. What's that all about?
That's a reinforcement.
Mm.
Um,
Got it.
from a printing standpoint, I'm printing it. Come on, let me. That's kind of the vertical that it's printing on.
It's so cool.
And so
Because it's
I,
one part. I mean, you've designed it at one part, but now you're showing this like, what is it, a component or a sub
right.
component?
This is one part. This is the two blade left blower. So this is if I go back to not sharing, this would be from here over. So that's basically what you're looking at. Would have been that portion of it.
Very cool. My compliments.
It's been a fun activity. I've also in the last since September started mentoring another First Robotics team.
And what are
Only
the ages of the participants?
that's the interesting part. We've got 5 6th grade girls, a 6th grade boy, and a 9th grade boy.
More girls than boys, isn't that?
Yes.
That surprises me. I mean, it shouldn't, I guess, but it does.
It's the same head coach that I worked with on the previous high school team that ended up placing second in the state of Minnesota.
Wow.
And their last robot had 57 3D printed parts on it.
Holy cow.
But they graduated 4 years ago. And so the team died. But the programmer, we had basically 4 main people on the team. The programmer turned down MIT to go to the University of Minnesota instead.
Goodness
Because
gracious.
he didn't want to go that far from home. Our CAD guy started out in architectural engineering, ended up changing to environmental, and he double majored in environmental engineering and robotics engineering, and already has 2 offers for when he graduates. He's going to be, it looks as though he's going to work for a toy manufacturer. But he ended up interning the last 2 summers for a paid internship with one of the mentors from our team. back
Wow.
then.
That's so cool.
So it's been a challenge, but I wanted to get back into 3D printing since we didn't have that mentor that had done all of the CAD and 3D printing on SolidWorks. I figured I'd better become the expert for our of the mentors on this tool. And I liked OnShape because one, you can get a free account that is fully enabled
Mm-hmm.
for if you're doing it for school or hobby.
Nice.
The only gotcha is everything you do is public, which for me, I don't care.
Yeah, big deal, you know.
It's not a big deal. But it's been fun. I'm gonna share it again. Some things that I've had fun with
If it's a full
is
license, then do they have, um, I'm sure there's a better term, but a stress analysis
they've
package
got
that
the analysis tools. Yes,
it'd be fun to figure out how to try to make that work.
but like putting in nut pockets. I don't know if you can see it on that.
Yep.
That was a fun little fun exercise to do. Or these I was able to draw and then just on the base and then just extrude up and then add the chamfers. But each of these had to be drawn separately because each support blade is tangent to the cylinder, but it turns around. So each of those had to be done individually.
That is so cool. And you know, in the what's the beauty behind 3D printing, as you know, is you just, if you can design it, it'll print.
Well, yeah. And I just got done doing another version of the left one, and I printed it with supports, and I'm playing around with different support mechanisms, but it takes a day plus 6 hours to print.
Yeah, I can imagine that.
And then this is the middle one that just connects here and here with the two blades on each side. And this blade, this will be the snow side, and they just match up perfectly,
Sweet.
which I was impressed with.
And what brand of printer did somebody let you borrow?
It's a Flash Forge Creator Pro 3. What's neat is it's a dual extruder.
So you can run two colors at the same time.
Well, I could run two colors at the same time, or I can run one with the PLA and then one with PVA support material that's water soluble.
That's clever.
I got the wrong PVA. It's not water soluble, it's water softening. But it becomes kind of like a thick gel and takes a bit more to work off.
Very cool.
But let's see. The person's gotten back to me at what time? No, he hasn't. Okay. But that's kind of where I'm at. What I'm wanting to do is build the blower piece of it and be able to test that out just just electronically and have it as a separate bolt-on to the robot. And then I'll next year or later this year, once I have assuming I get the the blower part done before the end of the snow season. Get that tested out so I can verify how to mount it, or how I want to mount it, but also how I want to control direction. Do I want to move the whole blower, or do I want to just add fans that direct the snow?
Hmm.
I kind of like to go with it just directing the snow, but haven't decided yet whether that's something that's doable or not.
Very nice.
I guess I was boring Jeff. He decided to go off and make some coffee or lunch.
Anything else you wanted to mention?
Not really.
Well, Jeff is gone and you've gone, so let
No,
me.
Jeff came back.
No, I meant he covered what he wanted to cover. Let's see. Since we last spoke, a few posts on Slack. Spent time getting Ubuntu 2404 installed on my Raspberry Pi. I made a number of mistakes along the way. First, starting with 2410 instead of 2404. Don't do that. You get a bunch of errors that 2410 causes. So I think it's sort of like the old days. Once you lock in on one Ubuntu, then you're locked in on one particular version of ROS, and it's in this case ROS 2 Jazzy. So, and then the instructions that I followed were from Automatic Addison, which I've followed him for a while and like his stuff, and only found one little glitch in the instructions, but worked my way through it. What this is a screenshot of a talker and a listener that is sort of built in. So getting to that point was a good spot.
And what will this Raspberry Pi 5 be doing?
In my replacing the laptop that was on my in my
Mower?
setup, yeah. So
Okay.
back in my Miro board, I had the setup where like I had one ESP32 with a number of sensors connected to it and a laptop up here handling ROS related stuff. So I'm sort of working on version 2 of this setup. This would be the quote unquote laptop would be the ROS 2 running on a RPi 5. And instead of an ESP32 down here, I was going to use the Teensy 4.1. So that's why you see my posts around trying to get stuff to connect up and work again, because my version 2 on my electronics board on my robot is going to be, I have a couple of key component switches. And I guess while I'm here, I also had an ESP32 over here for the radio control, and I just ordered my board designed on this Easy EDA for the version 2 of the radio control. So not only is electronics board changing, but the radio control is changing a bit too. Not a bit, basically swapping out the old version for a new version. So that's going on in my world, what that looks like at the moment.
So you're using the radio control to feed into ROS or to override ROS?
Both, I think, is how I would answer that. Practically, the way that my use case today is I start the tractor, drive the tractor to a safe spot, and start the automatic, start what I'll call the mission, start the defined set of waypoints. And so the radio control gets me from sort of the running position to the start position. And then if something is going on, there's a toggle switch in the system where I can say, okay, I take it out of auto mode, put it into manual mode, or vice versa.
Okay.
And this is on the Miro board, but I made some changes based on great feedback from Jeff. It's embarrassing for me to say how long does it take me to lay these things out. And Jeff looks at it and it's like, you don't need those resistors there. So I took out these resistors and through software set these pins as they're set to pull up on these pins. And so now I can get three logic modes out of one toggle switch. And I don't have to put those two resistors in. So once I made that change, I felt comfortable that I was ready to order the PCB board. And it takes, I think it'll take about 10 days ultimately from pressing order for the board to show up. So we'll see how.
What service are you using?
Uh,
Sorry, I'm catching up from the last
no,
9
that's fine.
months.
PCB Way, I think.
Okay.
These guys, Easy EDA, generate the Gerber file, and then you upload the Gerber file to PCB Way, and it's gone up. Price has gone up. It's now, like delivered $10 a board, but it certainly makes it cleaner and more professional looking to put it on a PCB.
Is that a double-sided board, and are you limited on size?
The price will change depending on. Mine is when you say double-sided, they have, I think, you can get 4 layers to the board. You can solder on 2 sides.
Right.
And so I think the price will change based on the physical size of the board, but mine were is $50 all in. So it was about $25 for 5 boards and $25 in shipping. But the physical size is basically the size of a PS2 joystick kind of thing, because all these will be mounted. This guy, How to Mechatronics, is sort of what I loosely followed my design on, and sort of what I was working towards. And that'll have a Teensy 3.2 inside of it, is what that, and then these are the potentiometers that I ended up going with. So it'll be, and then that's the toggle switch for the on or auto, manual, or sort of pause mode that I've got programmed in the software.
So did you get your Teensy mounted so you can get to the USB port on it?
I did. I moved let's see, I moved the Teensy up in the design so that I wasn't gonna, so I could get to that micro C, or it's whatever it is, micro. I moved it.
And the other option on that is if you put a socket to plug the board in, you can always pull the board off and then program it and put it back on. So that's another option you have on that. So you
Yeah.
still have that option at this point, either solder it down or do that. And I think you'd be happy in the long run if you do put sockets there, because as soon as you solder that down, you think, oh, now I'm screwed. I
Yeah.
can never take that off, because I did that somewhere and
Or
I
if you
learned my
do
lesson.
something dumb and burn up your board.
Yeah, that's another problem.
I agree. I intend on, although putting the socket raises the height, which makes the whole thing thicker, but yeah, I do intend on using sockets instead. Oh, the other changes, this is a significant change for me anyway, is it'll have the NRF24 as the radio communications instead of LoRa, which is what I was using previously. And the reason for that is I've been able to get 10 hertz connectivity, stable connectivity at about 900 feet. So, which is certainly well within what I would intend to do. And so, to your point, Jeff, this is a reasonably close facsimile, but I moved this up here and made the USB available at the top if I need it. Okay, back to Slack.
I know I was also telling you that you should put on a socket for both radios so you can swap them back and forth. It just occurred to me that your current radio is actually part of your ESP32 board, isn't it? So it's not like the ones I have. They're separate radios you could plug in.
Yeah. And then Bob was asking about power and to drive that RPi. I don't know exactly what I'm going to do. And Bob was, offering up some thoughts, but I found this on Pololu, which I was, surprised by the price and the footprint that this is giving 5.5 amps at 5 volts, down from 12 volts. So something like that is probably how I'm going to power the RPi right into a Lightning C connector, into the Lightning C connector on the RPi. They actually have one that's actually rated for higher than 5 amps. But I don't think I had found that when I made this post. But yeah, they've got a few nice options, I think, for figuring out how to power the thing. I also, on this, it takes some digital input, so I could actually put it in a low power mode. It's sort of effectively have an on-off switch instead of using some sort of relay. This could effectively become, digital relay too for powering the RPi, which definitely would make things good for me. Jeff, did you have any comments you wanted to make about power at this point?
Have you looked at that? The Pi 5 has like a power switch input on it. Have you ever looked at that?
No, I haven't.
And I don't remember if there's a push button on the board or there's simply pin that you can hook up an external switch or something to it. And that's the first board that they've done that with, as far as I know, that it does have some way to power the thing up and down. And I don't know what's involved with that, but that's something else you could look at. But
I mean, physically on the RPi, there is a button / LED that, if you go up to it and it's cold, it's plugged in but not running, you can press the button and it'll boot up, and you could power it down on that button as well. But that means having, physical access to the physical board.
or you might be able to use that and connect it to some kind of logic to pretend that it's a push button or a relay.
Mhm.
If you don't know what the circuitry is inside, I'll use a relay to look like a push button. So that might be another way, you know, if you're looking at different ways to get it to automatically power up and down.
Yeah.
And at one point I was looking at, you know, putting an external microcontroller along with a Raspberry Pi, and then that way, you know, you could set up to work like a laptop, you know, where you go walk up and push the button to get it to power up, and then when you're done, you push the power down, and it would be smart enough to tell it to, you know, go shut down all your running programs and all that stuff. And I never finished that, but I put enough thought into it that, you know, that should be possible to do all that kind of stuff if people want to do that.
Very cool. On to IMU activity. So part of my, you know, I'm version 2. Here's what I'm hoping. Version 2 of my tractor has. I'm hoping to have 2 GPS units to get heading off of. But in addition to getting heading off of 2 GPS units, I have an IMU, and I've been focused on using this BNO085 again from Adafruit. And I had, you know, it works fine. It's actually a super powerful little deal, but there's this, after I got it to work with I2C communication, I noticed this sort of warning. And because I'm using the Teensy 4.1, it's not exactly this RT 1011 chip, but it's an RT 1065 chip. So I'm like, well, son of a buck, I don't really want to have problems with this. And although I didn't, it's one of those things where I'm, if I had problems with it, I probably wouldn't know I'd had problems with it, because it does actually initialize and boot up in I2C. But I thought I better look at using SPI instead of I2C. So that took me down another rabbit hole, and that ends up with using a number of different pins. So to get SPI to work, so 1, 2, 3, 4, 5, 6 pins to get that to work. And so that was my journey over the last day or so. How can I make this bigger?
And then
Opening.
while we're right there on that, as you say, you ran across that warning, and it turns out that warning is from the Adafruit site. If you go to Adafruit and look up that module, they keep throwing that thing in there, and at no point do they tell you what the problem is. It just says, oh, you may have problems with this on certain processors, so you should use the ones that we sell. Or I don't remember exactly how they worded that, but at no point did they tell you what the problem is that you might have on that. So
Yeah.
I found that very annoying. Now it could be if you go out to either the Teensy forums or the Adafruit forums and put in this BNO085 and have, because I'm sure somebody else is asking, well, what is the problem here? Why are they saying that? But I just find that very annoying when they throw in things like that and don't explain it, and then you don't know, you know, like you're wasting a lot of time to get a different interface to work when it might work just fine with the first one, but they don't tell you that.
So, yeah, and the most I could find was, well, you might have timing issues. And I'm like, well, might, I don't know. A lot of things might happen too. But anyway, so to get SPI to work, the furthest I've gotten is I've got software running on this now that can see this. And I'm pretty confident now that it initializes, I'll be able to get the transactions out of it that I want. But it does take a number of wires to get all that to come together. And so for me, these are the pins that I'm using on the TZ. A couple of those, I think 26 and 27, are specific to the SPI one. I think it has 3 SPI potential ports, and my radio is going to use SPI 0. So that's why I was using this for one.
And
Yeah, that's what.
I don't want to confuse you there, but you can put multiple devices on one SPI port, and you can put and you can put multiple devices on one I2C port. But for what you're doing right now, for your own peace of mind, if you use a totally separate interface, then you get a good chance of it. You got a better understanding of the fact that you've got a separate interface and it's totally separate, so that's probably at this point the best way to go, unless you just really don't have enough IO pins to do everything.
Yeah, there was about a nanosecond when I said, well, maybe if I run the radio and the IMU over the same SPI, I'm like, oh my gosh, I don't. Trying to debug that for me probably would be beyond me. But so anyway, I physically had a teensy board and the IMU on separate little perf boards. And so that's what my gobbledygook wire looks like. And that's what it looks like connected up and running.
On that chip there, you can either run I2C or SPI. Do you get it? Does it work exactly the same way? It's just the interface is different. Because I was thinking the UART interface actually works. Don't you have different commands or something if you go to that one? So I'm just curious if it, you can get all the same stuff on either type of interface that you've played with.
Beyond the initialization, I was hoping it was, I don't know, I think is the answer to your comment. I've just gotten to the point where I've initialized it and I haven't actually read in the rotation vector, and I think I have to get a gyroscope and a rotation vector to do the math that I want to do. I don't know if the calls to the IMU are different or not based on the interface. I'm going to find that out later today. That was when it didn't work, and that's when it was found. So I had to go through my code and change the initialization steps, and I had to physically reset it, use the reset pin in order to get the thing to work. And I think I put the code out. Though I can't bring up the code that I put on Slack very easily for some reason. Oh yeah, there it is. So there's just the, so I had to put the reset pin in that, what do you call it? Substantiation or no, initiation, nah, whatever.
Well, guys, I have to call it a day, but thank you for allowing me to join.
Take care, Terry. I think that's all I had.
Okay, we'll see you later.
Bye.
Were you on vacation today? Is that why you're able to show up? No.
Oh, this is terrible.
So maybe he's on vacation is why he was able to show up today.
Could be.
So back to the comments on powering a Raspberry Pi. I started, Bob was going to jump into, oh, I'm going to do this. And, well, you might want to think about that a little harder. And he's, oh, I'm going to try this other way now. And I noticed that when you go looking at these sites, part of it is you have to look at them and decide, do these people actually know what they're doing? And that becomes a major issue at that point. I found one website, a guy says, oh, it's entitled, you can power your Pi 5 from the GPIO pins and still use the USB connector to do Ethernet. And he had all this whole list of things. And I was looking at that and I thought, he's one of the guys that will say, yeah, I hooked it up and it didn't explode. So I'm going to tell you, you can go ahead and do it too. And the whole point of powering it from the GPIO pins, I run into the questions here of this whole USB thing has gotten way out of hand. All the interfaces, it's got multiple interfaces on it. It's got this, you can power stuff through it or you can get power out of it. And now they got this new, what do you call it? Power delivery mode, the PD mode.
That's another confusing thing.
And then you can get, if you want, you can say, I want 3.3 volts or 5 volts or 9 volts or 12 or 20 volts. Well, you certainly don't want something putting 20 volts into a device that wants 5 volts. So that's more stuff to consider there. And but he's one of these guys. Oh, well, you just hook it up and it didn't explode, so you should be able to do this. And then finally, down at the end, he said, "Oh, well, you might want to put a resistor in series with the power on the USB port on that USB-C port, so it doesn't interact with something else." So I think he probably blew something up and decided to do that. But again, just looking at the stuff, you have to ask yourself, is that really what I should be doing? Because there was another one that somebody came up and said, well, I want to run this off a battery. I want to do this. And somebody says, well, just hook it up to the USB 3 port, which is one of I assume it's one of the little square connectors at the end.
Mhm.
And I don't think there's anything defined that says you're supposed to be putting power into those connectors. So that's more of the stuff that people are just randomly hooking stuff up. And I don't even know if hooking right up to the GPIO pins is really all that valid. I remember back on the old boards, like the 1, the 2, and the 3, people would say, yeah, you can power off that. And one person made the comment that, well, if you do that, you're bypassing a fuse that is in between your input USB port. It just had the micro USB on the side that you
Right.
hook up like a wall wart or something to it. Apparently between that and everything else, there's like a thermal fuse. What do you go? Resettable fuse is in line with that. So somebody just made the comment, if you bypass that, go right to the 5 volts on the pins, you don't have a fuse anymore. So just keep that in mind, is what they were saying. And the biggest problem is none of the stuff is documented. Since the Raspberry Pi is not open source, you don't know how they actually did this stuff. But there seems to be enough people saying, yeah, you can power it from the 5-volt pin on the GPIO and it will work. And you don't see a lot of people saying, yeah, I blew up my board because I went ahead and did this. But this whole thing with the micro C connector that's coming in, the USB-C connector coming in, it's got all that extra stuff on it. And I was thinking, well, does it have this power delivery mode stuff built in? Did they support that? And my thought was, no, they probably didn't do that, because it seems like that'd be a real pain to do all that. And then finally I ran across a post where somebody said, I want to hook this up, and somebody asked about, they said, well, I'm assuming the Raspberry Pi did not implement that function, because why would they, or something like that. And the next guy posted, says, well, it says right in the spec on this page, it says it has a micro or it has a USB-C port with power delivery. So that's right on the Raspberry Pi page in their specifications. And that's the most I could find out of it. Nobody seemed to go beyond that as far as what that's going to do, or but they said, well, so the Raspberry Pi 5 will do power negotiation, which I think what that means is you can plug that into one of those, you can buy the big USB batteries that you just like back in the old days, you'd plug it in, it would put out 5 volts. Well, the new ones, apparently, if you hook it up to it, it'll go out and say, oh, give me 20 volts instead, or whatever. So technically, I think that's saying that my guess is, and I'm only guessing because I can't find this anywhere, that if you plug in your Raspberry Pi 5, I'm guessing it wants 5 volts. And if you plug it into one of those devices, maybe you have to tell it what you want. So when you plug it in, it would go out and say, yeah, give me 5 volts, and everybody would be happy. And then I found another page late last night that said something about, he was talking about how do you power these things. And he came down to the point, because he was trying like different wall warts and stuff on it. And this is, I think, got a Pi 4 that he's playing with. Now again, I'm making a rash assumption. The Pi 5 and the Pi 4 are basically going to work the same way, because they got the same kind of connector and the same evolution. And he down at the bottom, he said something about, if you put in 5 volts at 5 amps, it will work. And so that leads me to believe that, whether it's got that power negotiation or not, if you put 5 volts in, it will power up and run. But again, you have to ask, did he really know what he's talking about? But he claims he worked in a university lab doing this kind of testing all the time. And it turns out, if you follow his page, he has different articles he wrote on doing, measuring the power and doing all this kind of stuff. So I would tend to believe him more than the other guy says, oh, I hooked it up and it didn't blow up. That, back to that guy's page, you said, so you could use that USB port for things like Ethernet and all this other stuff. Well, I think what he's saying is that if you possibly, and I've never done this, but if you go look at your your Linux stuff, when you fire it up and then go look at it and say, does that port show up as a USB port? It might actually show up, because you got the 4 ports on the board, the normal ports on the Raspberry Pi, and then that one might show up as a 5th USB port somewhere,
Hmm.
in which case it might be a full USB port. But so I also made some rash assumptions when we first started talking about this, or when you and Bob were talking about it. I looked at it and thought, well, I assume the way that works is you plug in an external cable and it would connect by USB and say, here's what I want for power. This is what's available or whatever. But then one of the last things that Bob posted, it took me out to a page, and under there it says, oh, here you should get to know more about USB-C, and there's a link, and it goes out to a microchip app note, and it's like a PDF file, and it goes into great detail about how all this stuff works. And down just briefly, casually looking through, it said something about power negotiation at 300 kbaud. So apparently it's not using USB. They've got an extra interface on there, because when you look at it, it's got like 20 pins or something on that. And I think they've got an extra interface that goes out, and that's its sole purpose in life, is to talk back and forth and say, this is what I want the power to do. And so I was happy when I saw the one guy say, oh, if you just put 5 volts on, it will work, and he seemed to, but that's, again, that was on the Pi 4. So I don't know if the Pi 5 works the same way. And one of my assumptions was, well, it seems awfully complicated to do this stuff. Why would they put that on there? But it's probably down to the point where it's, you just buy a chip and hook up to that thing and it all works. It just gives you all that stuff for free. So that's probably why, one reason they would actually implement that, because, you get this chip that does the USB stuff and you just stick it on there and it knows how to do all that. So that my only concern would be, is the board going to be saying, oh no, I want to switch voltages now because I need more power or something? And if you just have it hooked up to 5 volts, it can't do that. So that would be something to look into. And possibly if you go look up, look up the actual wall wart that Raspberry Pi sells. Maybe if you go to the Raspberry Pi site, they'll give you more details on it. But I maybe go to Hackaday or somewhere and say, has somebody taken one of those and analyzed it? Does it do the power delivery mode, or is it just put out a straight 5 volts? That would be, a good way to find out on that. And but you can just go ahead and try it. I think if you just put the 5 volts on that connector, probably it will work. And then, if you try things like loading it down really hard and make sure it's not trying to switch to some other mode, because if it tries to switch to a different mode, it may or may not let you know that it doesn't like that. I don't know if it'll show up in the under Linux. Maybe you do the D message and it's telling you all the things that are happening. It might say there that port just requested more power or something. I don't know. I'm not sure where to look next to figure this stuff out. But it seems like half the key is the board itself, the Raspberry Pi or the Pi 5 or the Pi 4. It's going to work one way, but then the wall wart, if they're selling a wall wart to go with it, it may have some special functionality, and it would just be interesting to find out, or it might be important to find out what that module is going to do. But I've seen enough people, just taking like a USB charging battery, put a cable on and plug it into the board and it works. And so I'm guessing that, yes, it probably will work if you just power it through that connector they intended for you to put power into.
Right. That's my intent.
And
to
also, since it's got all that extra weird stuff going on, it just seems like you're better off going through the connector they intend for you to power it with. That you might be better off doing that as opposed to, say, putting power into the GPIO pins. But I don't know at this point, what actually makes sense. I was just randomly looking at this stuff as people would post things, say, oh, here, try this, or I found this other stuff. And so that's kind of what I was looking at, and that's how far I got. And I had a bunch of links on my other computer. I should have sent them down here so I could have posted them in the chat. I still do that after the fact, but we can't go look at them right now because I don't remember what they were.
Yeah, I was at the point with my laptop that I was going to have to get a step up converter to get from 12 volts to what my laptop needed. And that was part of the impetus to say, well, maybe I'll just try a Raspberry Pi 5 And on that, I'll just share briefly when I was going through, Automatic Addison's stuff on installing this. He's like, install Gazebo. And I'm like, oh man, do I really want to try that on this Raspberry 5? And so I went ahead and did it anyway. And I was just shocked that it fired up Gazebo as good as my laptop would have. And I'm like, holy cow, this little thing has got some muscle to it. I mean, like you could mess around with the sliding bars and everything on the Pi 5. So my reading on the whole power thing is, without any USB things running, it needed like 300 milliamps. Didn't even use an amp to, just to run the Pi. It's when you start putting on a bunch of other stuff that draws power, that's when you get up to the 5 amps. And so I'm pretty confident that as long as I think I'm going to get the voltage regulator that is actually rated for more than 5 or 6 amps. And I think I'll be fine. So, but it is
somewhere on that particular, I think I was looking at this page, and they give a little chart somewhere. It says based on the voltage in and the voltage out, and then this is how much current you can get. So somewhere there's a table that tells you that kind of stuff. I think it was on this page is where I found that. So you just scroll down. I think but they show you a little chart that tells you what you need to know.
Yeah, it may have been on the other one, but let's scroll down and see. Oh, that's this one. Yeah.
And then I think it was like a link. They didn't, so you had to click on the link to see it, but it's the same kind of thing where they were just showing, see this one's showing a VN, and then
well, this is efficiency.
yeah, and then it says V out is 5 volts. So the other one I think was telling you basically the same things, but I think they were showing how much current. Like this one. This is the one here.
Continuous, maximum continuous output.
Yeah, so if you look at this one, and it looks like, in the range you're going to be running it for like 10 to 12 volts in, it's pretty flat there. I think it was the black one, which is the 5 volt. It's the green one. So that those look, it's saying it'll give you 8 amps over, if putting up to 20 volts into it. So
yeah, that's that particular version.
Although look at that thing right at the bottom. Look at that warning down the bottom. It says during normal operation, it's hot enough to burn you.
Yeah.
So keep that in mind that the thing is going to run hot apparently. So,
but if I get this 50 or V50, I'm going to be running it. I don't think I'm going to put a bunch of stuff on it. So, maybe I'm running 3 amps. I'm going to be well within operating specs on that for continuous operation. So,
yep.
And here's their talk about this. I don't even know how to pronounce that, but you can put the board into low power state. So if I change that state, I don't know if the RPi will come back to life. I think it will, but we'll have to test that. But the point being, I think I'll be happy instead of trying to power my laptop with 12 volts, powering this with 12 volts, I think is going to give me a smaller footprint and yeah, have enough beef to run what I want to run. So pretty excited about that.
So is this the Raspberry Pi that was going to be your RAID backup system, or did you get another one?
I made my way. It's another one. I made my way to Micro Center in Columbus, Ohio, and picked up one for, I think you can get one a month for $69.99 at the Micro Center in Columbus. The 8 gigabit version. So I should say that because they have 2 or 3 different versions there.
Yeah, I checked our local store and they're sold out of everything except for maybe you can only get Raspberry Pi 4 is all they got right now. So it's just a matter of, do they have them in stock? And you got to check if you could drive a long ways, make sure it's in stock before you drive to get it. So that's yeah, you learn those things as you go on too.
But on the NAS, I did get to, my issue was my hard drives, my cheap Chinese clones were not having it. So I got Crucial, I think Crucial disk drives, and yeah, the smaller ones, NV, or the piece that plug into the PCIe port, and it's running fine. So pretty happy with that. I think that's all I've got for recording.
Let's see, what did we talk about? I talked about power. I see. I'll try to go through some of put a few of those links out. I'll either put those in put them in our chat section for the description, or I could post something to. Most of the stuff was posted on Slack anyway. I just went through and said, here's some things you can search for, and that brought up a lot of stuff. But that's when I started noticing you should read. Don't take the first thing you find and assume the person knows what they're talking about. Look at multiple pages and find out if everybody seems to be agreeing on this stuff. And even if everybody's agreeing, that doesn't mean that's right. That's another thing you need to keep in mind. But and then that thing Bob posted, he said, "Oh, you can buy this little connector from Adafruit that's got the the connector will plug in the little printed circuit board, so you can just solder you two wires onto that." Otherwise, if you get I suppose if you just went out to like Amazon and bought a USB-C charging cable and make sure they say it's verified for 5 amps or whatever, then you can just cut the one end off and hook that onto solder that on your power supply or something. That might be another way to do that, so you don't have to build the one connector at the end. But it never occurred to me you could buy just the little adapter board like he showed on that.
Yeah,
And
that was an interesting find.
in fact, let's see, how could I bring up Slack here? Let me try this. Let me do this. Okay, let me do this. And then that's this page, I think. Okay, and it shows, yeah, that should be showing.
Yes, I see it.
Way. These out of the way. So let's go back to random. So, oh, what's this last one here? It's out on Slack. Just in the last couple of days, Bob posted this. Well, that's not what I was looking for. I think it was in this one. This is the one that led me to it had that PDF where it said something about you should learn more about how USB-C works, and then no.
I mean, they tend to confuse things by mentioning that USB-C PD, which, I mean, I'm going to give it 12 volts. I don't need to be plugging in my RPi to something different every day.
Say that again.
That USB PD,
Yeah.
that it's a nice feature, but it's like, it's not anything I'm going to need.
You just said you're going to put 12 volts into your Raspberry Pi, or you still
only through a power converter.
Okay. Because I don't believe that's what you said. I don't want people to think you're going to put 12 volts into that, expect it to work. So anyway, this is the thing that Bob had posted, and somewhere in here, this is the one where somebody went through and said, "Oh, I'm going to try all this," and then the next guy says, "Oh, just hook it up to your." I'm sure you can't read in that. That's way too small. Let me try this. There we go. He says, "Oh, just hook it up to your what do we call it? USB 3 port." And that's and somebody else says, "Well, I don't know if I do that or not." So right here, he says he's used a buck converter to power the USB 3 port because it only has 4 wires on it. Well, I don't think you're supposed to be putting voltage back into those connectors, and maybe this stuff works better than I think it does. But so that's not what I was looking for. Where did I see that? Let's see, how do I get back out of here now? La 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 la. Come back to here.
I thought it was in one of his posts, Bob's posts.
We'll have to find Bob's posts here first. So I can do like this. I think it was the very end of this one down here.
Mm-hmm. I recall that as well.
Well, maybe I'm not gonna be able to find it. Started doing that. Thanks. Blah blah blah. Think about attaching.
It's right there.
What, you see it?
I thought I saw it. Go to where the battery. Stop. Scroll up.
Well, this is some of the early
Oh,
stuff
that's
here.
what you put there. I'm
I
sorry.
put that there. So let's get out of the thread because it's not there. How do I do that? Like that. And then come down here. So, oh, there it is. There. No. Raspberry Pi. Let's see what this says. Okay, that's what I was just looking at. And so to apply. So it's got to be this one. Here it is. Yeah, it's this one here. So you can buy just this thing. It's got the connector that'll plug in,
Right.
and then it's just got a little printed circuit board, and it's got like two big power connectors there. And this is probably the two data pins. And this is something else that I find annoying. They show you that one, you see this one. Well, it's from the same side. They show you that one's from the same side again. And then eventually, I think they do show you the back of it here. So it's got that. I can't tell if you can put little option resistors on there or not, or if it's just to get power and data in and out, which this should work just fine for what everybody wants to do. So if you go back to the first one here, go to this one here. So if you look at this one, I do that. Boy, there we go. So it says V and G for voltage and ground. It's got your plus D plus D and minus D. So it's got your four basic wires to make USB work. And I don't know if it's got anything, if it'll do it. I didn't look at this real hard, but for $1.75, you get that and solder your wires on and put some heat shrink over it and be ready to go. Or I was thinking you could just go out and buy a USB charging cable and cut one end off to get your power lead. So that'd be another option on that. So, but it didn't occur to me to just go out and buy this. So apparently you can. And let's see, anything else? That's probably all I wanted to show there. So it's just a matter of, physically, how do you do this stuff? And it's good thing Bob's on his toes here and realizes that stuff exists. So let's see, blah, 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 Raspberry Pi 5, blah, blah. Again, can't think of anything else. So I guess I'm done. Stop recording.